let's try to solve this regular old line integral, which is the scalar line integral, usually given as f ds, and that's exactly what we have here. We could turn that into a parameterized version by saying a to b, those are the time limits, f, and then we're going to try to plug in the x and y values in terms of t, given by this curve, potentially a z, just in case I might have a z in this one. So z, t. And then I'm also going to multiply that by the magnitude of the r prime vector over dt. As we know, the r prime situation can be discovered by saying basically the x derivative squared plus derivative of y squared plus the derivative of z squared. That comes from this. So let's start by trying to find the r prime of t situation. We're going to go rt equals this. So we could say 3 minus t, we could say -1, and then we could say again 3 minus t. Then we're just going to take the r prime of that, which is going to be -1, 0, and a -1. And then we're going to go ahead and do the square root thing, which is going to be 1 plus 1 under the square root. So that's the square root of 2. And that is what the r prime of t thing is. So just keep in mind that this is r prime of t, and that'll kind of come outside the integral's content. But let's try to figure out what this is as well. Let's see if I could try to get this set up. So here's the square root of 2 outside. The t's are going from 0 to 2. And let's put that in there. Well, x squared is this. So we'll say 5 times 3 minus t squared plus y squared is just 1. And then we're going to divide that by the z squared on the bottom, which is just 3 minus t squared. And then we're going to have the dt, because everything is in terms of t's here. Now, there's two ways that we can solve this. One way is to expand this all out and try to use long division, which is kind of what I first did. But then I realized I could just split this up. So I could basically say 3 minus t squared divided by 3 minus t squared. And then I'll just add 1 to the other side. So 3 plus t squared. And this is minus right here. But yeah, so these will just cancel out. And now we're just trying to integrate that and that. This is a very easy integral. Square root of 2 here, 0 to 2, dt. So you're trying to integrate 5 and then plus 3 minus t to the -2. Square root of 2. Let's go ahead and do that integral. It's just going to be 5t plus 3 minus t to the -1 divided by -1. And this is going to go, from 0 to 2. 0 to 2. Let's simplify this one last time before we do that. We'll say 5t minus 1 over 3 minus t. Just a little bit easier to read that. Square root of 2. So we'll get 10 minus 1, and then minus, I'm going to plug 0 in there. We're going to have to add in a third at the end. This whole thing times the square root of 2. And I think the calculator shows something like 28 divided by 3 square root of 2. So yeah, that would be the correct answer.